A silent object moved across the sky, unseen, unnamed, cold. It wasn't a star. It didn't shine with hope. It carried an ending, and we didn't see it until it almost saw us. Chapter 1. A late discovery. The arrival of 2020 for Year 4. There are objects in space that don't glow, don't spin, don't speak. They drift, silent and cold, like forgotten memories of a universe that no longer cares. On December 27th, 2024, while the world prepared for fireworks and champagne, one of these objects quietly entered our story. A telescope at the Torino Sky Survey in Arizona spotted at first a faint dot against the stars, barely moving, barely noticed. They gave it a name, 2024 Year 4. At first glance, it seemed harmless, just another piece of space debris. But then came the numbers. Its estimated size ranged between 53 and 67 meters in diameter, larger than the meteor that once shattered windows and injured over 1,500 people in Chelyabinsk, Russia, in 2013. That event, though terrifying, had been unexpected and brief. 2024 Year 4, on the other hand, was still approaching, and we were watching. It was quickly classified as an Apollo-type asteroid. That one detail changed everything. Apollo asteroids don't just orbit the sun, they cross the Earth's path. And crossing paths in space often means coming close enough to matter. In the days that followed, astronomers around the world started tracking it more closely. Its orbit was unstable, shifting slightly with every new observation. Predictions were updated hourly. At first, they said it would pass safely. Then they weren't so sure. By February 12, 2025, the asteroid was officially rated a level 3 on the Torino impact scale for the public. That number didn't raise alarms, but within the scientific community, it meant something serious. A level 3 rating indicates a real possibility, something not just theoretical. That put Year 4 in rare company. The kind of event that doesn't happen every decade. The impact zone, if it were to strike, could cover over 2,000 square kilometers. That's not a scratch or a crater. That's the size of a region, one capable of housing millions of lives. The concern wasn't whether Earth could survive it. Earth has endured worse. The concern was whether we would see it coming in time and what it might leave behind. To understand the potential damage, researchers looked to the past. The meteor crater in Arizona was formed roughly 50,000 years ago by an asteroid even smaller than YR4. The result was a hole, more than a kilometer wide and 170 meters deep. A single moment of impact, frozen in stone. Then there was Chelyabinsk, a reminder that you don't need an impact to cause devastation. That meteor exploded in the sky with a force equivalent to several hundred kilotons. Windows shattered across 6 cities. Thousands were injured by falling glass alone. The asteroid never touched the ground. Year 4, by comparison, was larger, faster, and possibly more direct. What made it worse was how little time we had. Discovered just days before the new year, and escalating to a level 3 threat within weeks. Year 4 represented what experts fear the most: late detection. Space is vast, and even the most advanced systems can miss something small, especially if it's dark, fast, and approaching from a blind spot. But Year 4 wasn't just fast. It was also odd. Its trajectory didn't behave exactly as expected. Minor shifts were observed, tiny deviations from predicted paths. Most could be explained by normal factors: gravitational pulls, thermal forces, even observational error. But some data didn't quite add up. At one point, YR4 passed unusually close to the moon. It was nearly obscured, as if it had hidden behind our lunar companion for just long enough to confuse the tracking models. That kind of alignment is rare. Coincidental, maybe, or maybe not. Some scientists raised quiet questions. Could it be accompanied by debris, or something else? Something not natural? Officially, these questions were dismissed, but among closed circles, the idea lingered because space is full of things we still don't understand. Then, just as quickly as the threat escalated, it was gone. In late February, just weeks before the projected closest approach, new data showed a sudden shift in trajectory. YR4 had altered its course. It would miss Earth by a significant margin. No impact, no airburst, no crater. Relief washed through newsrooms and observatories. It had spared us, or we had simply been lucky. The change in direction was explained by gravitational influences, perhaps an interaction with Earth's outer magnetic field, or a tiny push from solar radiation. But some still weren't convinced. Objects like YR4 don't usually behave this way. They don't hide behind moons. They don't show up late, raise threat levels, and then disappear. Not without a trace. Not without a reason. The public moved on. The world turned its attention back to politics, whether entertainment, but for the scientists who watched it, and the quiet observers who stay up late staring at the stars. YR4 became a symbol, a warning, a silent reminder that the cosmos is not empty, that danger doesn't always come with sirens or headlines. Sometimes it comes as a faint dot, moving slowly, quietly, almost politely. 202 for YR4 is now considered a near. It will return in decades, perhaps centuries, or perhaps not at all. Some believe it was a one-time visitor, a messenger. Others believe it's still out there, circling, waiting for the right trajectory, the right angle, the right moment. The truth is, we don't know. And that's the part that stays with you long after the calculations are over. Because the real story here isn't about impact probabilities or crater sizes. It's about awareness, about how close we came to something we couldn't stop, something that doesn't care about borders or language or time zones. Space doesn't play favorites. It just moves, cold, silent, constant. The next object may already be on its way, smaller or larger, slower or faster. It might be discovered weeks in advance, or minutes. It might pass safely, or it might not. For now, the sky is quiet. But if you ever find yourself unable to sleep staring up into the darkness above your ceiling, remember this. On a quiet night not so long ago, a piece of space came close enough to matter, close enough to be remembered, and then it left. No sound, no fire, just silence. The kind that makes you wonder what else is out there, and whether next time we'll see it in time. Chapter 2. A Race Against Time. There are objects in space that move without noise, without purpose we can understand. They do not glow like stars. They do not follow the rules we expect. They drift, dark, ancient, indifferent. On December 27th, 2024, one such object was seen crossing the sky by a telescope at the Catalina Sky Survey in Arizona. It was small and dim, barely a dot, but it moved differently. Its name was given soon after, 2024 Year 4. At first, it seemed like just another asteroid, but its size was notable, between 53 and 67 meters in diameter. That made it larger than the Chelyabinsk meteor, which had exploded in the sky over Russia in 2013, sending shockwaves across 6 cities and injuring over 1,500 people. 2024 Year 4 wasn't just larger, it was on a more direct path. And worse, it belonged to the Apollo class of asteroids. These are not distant wanderers. They are known for crossing Earth's orbit. Day by day, scientists tracked its path, calculating possible outcomes. At first, estimates showed a distant pass. Then the margins narrowed, and on February 12, 2025, the asteroid reached level 3 on the Torino impact scale. For most people, that number meant little. It didn't make headlines. It didn't cause panic. But for astronomers, it was deeply concerning. Level 3 is not theoretical. It reflects a situation that requires attention. A real possibility of impact, not inevitable, but serious enough that observatories around the world began monitoring it without pause. The potential blast zone was estimated to be around 2,000 square kilometers. To put that into perspective, it's larger than some countries. If that area included a populated region, the consequences would be severe. An object of that size, striking at high velocity, would release energy many times greater than the Chelyabinsk event. If it hit a city, any city, that city would be gone. To understand the stakes, scientists turned to history. About 50,000 years ago, a smaller asteroid struck what is now Arizona, creating the famous meteor crater. That impact left behind a hole over a kilometer wide, and that asteroid was less massive than 2024. Year 4, then came Chelyabinsk, a more recent and vivid reminder. That meteor never touched the ground. It exploded in the atmosphere, yet it was strong enough to shatter glass across thousands of buildings. The threat from Year 4 was greater. It was larger and potentially deeper in angle. An atmospheric explosion, or even a surface impact, could level infrastructure across a vast area. It wouldn't be a global catastrophe, but it would be a devastating local one. And the worst part was the short notice. The asteroid had only been discovered a few weeks prior. Late detection is one of the most worrying realities in planetary defense. Despite our telescopes and sky surveys, small dark objects can still approach unnoticed, especially if they come from blind spots near the sun or from high inclination angles. In the case of Year 4, its trajectory seemed to evolve with each observation. At first, it was consistent. Then slight shifts were noticed, small enough to be within error margins, but strange enough to cause concern. And then came the moon incident. As Year 4 moved closer, it passed behind the moon for a short period, disappearing from sight. That, in itself, is not unusual. But the timing was uncanny. The moon, for a brief moment, blocked the asteroid completely, making it impossible to track. When it reappeared, its path had changed slightly again. Not dramatically, but enough to confuse the models. Some experts suggested gravitational interaction with the moon had altered its path. Others wondered if we were seeing the effects of thermal forces, known as the Yarkovsky effect, where heat absorbed from sunlight slowly shifts an asteroid's motion. But a few scientists privately raised another idea. What if Year 4 wasn't alone? This was not a claim of fiction, but a technical possibility. Binary asteroids exist, asteroids, with small companion rocks or fragments that travel together. Could YR4 have a shadow, a smaller object nearby influencing its movement? Could radar signals have bounced off more than one surface? These questions had no answers, and with each passing day, the tension grew. Then, just as quietly as it had appeared, 2024 YR4 changed course again, this time, significantly. New projections showed that it would not impact Earth. It would pass at a safe distance. The risk level dropped from 3 to 1, and eventually to 0. For the astronomers watching it, the moment brought relief. The threat was over, but the mystery remained. What caused the shift? Was it gravitational? Was it thermal? Or was it something else, something we didn't detect? The official explanation pointed to the most likely variables: gravitational nudge, observational correction, and updated trajectory modeling. That was enough for the headlines. But the story beneath the numbers lingered. An asteroid of that size, appearing with short notice, triggering impact concerns, displaying minor anomalies, and then veering away. That sequence left many scientists uneasy. Space is full of objects like YR4. Tens of thousands of them drift silently near our planet, mostly harmless, mostly small. But it only takes one to matter. One object at the wrong time, on the wrong path, could change everything. And while our tracking systems improve, they are not perfect. Late discoveries are not rare. Sudden course changes do happen. And even when all data points to safety, the unknown still exists. 2024 YR4 is no longer a threat. It is just a number in a database, a blip in our long list of near-Earth objects. But for those who followed its path, it is more than that. It is a symbol of how fragile our place in the cosmos really is. We do not control what moves out there. We only observe, calculate, and hope we are right. This time, we were, but one day, we might not be. And so the sky remains quiet for now. But the next time you find yourself looking up at the stars, unable to sleep, remember this. Above our atmosphere, beyond the clouds, beyond the satellites, countless rocks continue their silent journey. Most will never come close. Most will never matter. But one might. And if it does, we may only have days, or hours, or minutes. And by then, the sky will already be falling. Chapter 3. When the past haunts the future. Some stories begin with what might happen. Others begin with what already has. When 2024 YR4 appeared in late December, it wasn't just its trajectory that drew attention. It was the memories it awakened, fragments of past impacts, past warnings, past close calls. Scientists didn't just look forward, they looked back, and what they saw reminded them of just how real this kind of threat has always been. 50,000 years ago, something smaller than YR4 struck what is now Arizona. It came from the sky at incredible speed, invisible to anything that could have warned the life below. The result was a hole in the Earth 1.2 kilometers across, nearly 200 meters deep. Today we call it meteor crater. Tourists visit. Photos are taken. But when you stand at the edge and look out, you understand that this wasn't nature carving a canyon over centuries. It was a single event. One object, one moment, and that's all it took. More recently, in 2013, a flash of light appeared over Chelyabinsk, Russia. People looked up. Then came a shockwave. The meteor that caused it was just 20 meters across, about a third the size of YR4. It exploded in the air, never touching the ground, yet its force shattered windows in over 7,000 buildings and injured more than 1,500 people. There was no warning, no countdown. It arrived, it burst, and it left a trail of glass and confusion. That was an airburst, a phenomenon where a space object breaks apart in the atmosphere, releasing energy downward like a ripple through the sky. When scientists modeled the potential outcomes of Year 4's approach, they considered such scenarios. If it entered at a shallow angle, it might not strike the surface directly, but that wouldn't make it harmless. In fact, a mid-air detonation could spread its energy even wider, over hundreds of kilometers. One physicist remarked, carefully, that it would resemble a small nuclear detonation without radiation. The comparison isn't sensational. It's about energy. It's about scale. An asteroid of that size, traveling tens of thousands of kilometers per hour, carries more kinetic energy than most weapons ever built. And it doesn't need to explode on impact. The atmosphere itself can trigger the release. A flash, a shockwave, and then silence. The haunting part of history is that these events weren't isolated. Earth has been struck before, and it will be struck again. The scars are there in the deserts, the oceans, the forgotten layers of rock. But most of the time, we forget. The sky seems calm, the stars distant. Our days are filled with noise, not silence, until something like Year 4 reminds us that above our heads is a system we don't control. Objects come and go. Some are tracked, many are not. And that's what made Year 4 so unsettling. It wasn't just a hypothetical danger. It was real, observed, measured, projected. It passed every threshold, required to become a threat, and then hovered on the edge. The historical comparisons weren't there to alarm. They were there to inform. They were used to estimate pressure waves, heat signatures, impact depths, potential casualty zones, because if it had come closer just a few degrees different, just a few days off course, it wouldn't be a story told in the past tense. It would be a headline, a memory burned into cities and families, the kind of event that leaves a mark not just on land, but in culture. And yet, it didn't happen. The asteroid turned. Or perhaps we miscalculated. It passed safely. And that's the strange thing about disasters that don't occur. We never truly see the line between near and never. All we have are simulations and scars. For those who spend their lives watching the sky, it's not about fear. It's about readiness. It's about understanding how close we've come before, how close we came this time, and how little room for error there really is. Because somewhere, even now, another object is drifting, dark, silent, indifferent, not hostile, not guided, just moving, carrying the same energy, the same risk, the same story waiting to be written. Maybe it will miss us. Maybe not. But history says one thing clearly. What has happened before can happen again. And that knowledge lives quietly in every observatory, in every sleepless scientist reviewing orbital paths, in every forgotten crater, half buried by time, in the quiet spaces between stars, and perhaps in the silence just before the next flash of light crosses our skies. Chapter 4. Strange Coincidences. From the beginning, 2024 Year 4 didn't behave like other near-Earth asteroids. It didn't follow a perfectly smooth arc. Its movement wasn't as predictable as models had suggested. Each new observation seemed to bring a small correction, a wobble, a deviation, subtle but undeniable. At first, scientists attributed it to observational error. After all, these objects are faint, distant, often only a few pixels wide on the most powerful instruments. But the wobble persisted. It was as if something unseen was gently tugging on the asteroid, altering its path in ways that didn't quite match the expected physics. Then came the moment that turned quiet concern into deeper curiosity. As YR4 approached the Earth-Moon system, it passed behind the Moon from our vantage point. That in itself isn't unusual. Countless objects drift behind celestial bodies every year, but the timing was strange. It happened just days after YR4 had been discovered, just when its position and trajectory were being refined. For a brief period, the object seemed to vanish completely. When it re-emerged, its position had shifted slightly. The models had to be updated again. The proximity to the Moon had affected its path. That much was certain. But had the Moon alone been responsible? Or was there something else at play? Gravitational influences from nearby bodies are common. The Moon, Earth, even the Sun all exert force on passing objects. But some researchers noticed that YR4's motion deviated slightly more than expected. Even when accounting for these known forces, it was as if the object had responded to a pull not in the data. Some quietly raised the possibility of a companion object, another small body traveling with YR4, invisible to our instruments, but capable of exerting just enough influence to disrupt predictions. Binary asteroids do exist. In fact, they're more common than previously thought. About 1 in 6 near-Earth asteroids are believed to have a smaller companion, orbiting or loosely bound by shared momentum. Could YR4 be one of them? Or could it be something even stranger? Among a handful of theorists, a quiet question was raised, not shouted, not published in headlines, but shared in closed discussions. Could there be something artificial involved? Not in the sense of science fiction, but in the sense of an unexplained structure. Perhaps a long-lost fragment of a human-made satellite or spacecraft, drifting silently in tandem with YR4. The solar system is full of debris, and not all of it is tracked. Could something have latched on to YR4? Could a forgotten piece of metal be caught in its gravity, or nudging it just enough to confuse our instruments? The idea was speculative, unsupported by clear evidence. But it was difficult to ignore how YR4 had evaded detection for so long, only to appear, then disappear behind the Moon, then reappear with a shift. All of it happened in a narrow window of time, just enough to raise eyebrows. Of course, the official explanations remained grounded. Most experts pointed to gravitational perturbations, the Yarkovsky effect, and the challenges of tracking small objects moving at high speeds. These are real, measurable factors that can explain much of YR4's behavior. But something about this one felt different. It wasn't just the data, it was the timing, the angles, the brief vanishing act, the irregular path, and the way it all lined up in such a short period made even the most cautious researchers wonder. Not everything in space is mysterious. Most things, in fact, follow the rules of physics as we understand them. But every so often, an object comes along that resists full explanation, not in dramatic ways, but in small, persistent details. Details that don't go away. YR4 was one of those. It came from nowhere. It behaved oddly. It lingered in uncertainty. and then it turned away, as if it had finished whatever path it was meant to travel. Whether there was something else near it, natural or otherwise, we may never know. The instruments we use are powerful, but space is vast and our understanding still limited. What remains are the questions. Why did it shift when it did? Why did it nearly vanish behind the moon just as we began tracking it? And why, after all of that, did it change course? The answers may lie in physics, or they may lie in things we've yet to discover. In the end, Year 4 reminded us that not every close call is straightforward. Sometimes, even a rock from space can leave behind more questions than certainty. And sometimes, it's the ones that leave quietly that stay with us the longest. Chapter 5. An unexpected ending. Then, something happened that no one fully expected. After weeks of uncertainty, after warnings and projections and close tracking, the asteroid known as 2024 Year 4 did something surprising. It changed direction. Not by much, just enough. Enough to miss Earth, enough to avoid the moon, enough to shift the story from disaster to mystery. It didn't slow down. It didn't break apart. It simply veered away. The models had predicted a narrow pass, perhaps even closer than any object its size had come in recent years. But now, it would pass at a safer distance. The risk level was downgraded. The headlines faded. The urgency dissolved. And yet, the question remained, why? Official explanations were cautious. Some pointed to gravitational nudges, perhaps an interaction with the moon's pull, or the subtle push of sunlight over time, known as the Yarkovsky effect. Others considered it a correction in our own data, an improvement in trajectory, measurements that refined the path we thought it was on. But beneath those technical reasons, there was a quiet unease, because the change had come late. Almost too late. And because, no matter how carefully the data was the shift didn't entirely line up with previous predictions. It was as if the asteroid had made its own decision, not guided by intention, but by a set of influences we hadn't fully accounted for. For scientists, this was not the first time an object had acted unpredictably. Small changes happen. Models adjust. But with Year 4, the timing made everything feel different. It had appeared suddenly, been watched intensely, behaved strangely, and now, in the final stretch of its approach, it simply left. No impact, no trail, just a silent withdrawal from the space between Earth and Moon. For the world, it meant relief. For those who had stayed up through nights running simulations, it meant questions. Did we get lucky? Was this always the plan? Had our early data simply been wrong? Or had we witnessed something we didn't fully understand? The answers didn't come. There was no anomaly report, no urgent press release, no classified revelation, just a quiet note. 2024 Year 4 would not pose a threat, and then it passed. No flash, no sound, no trace. Objects like Year 4 are reminders, lessons carved in stone, not through impact, but through possibility. They show us how thin the line is between calm and chaos, how little time we might have if things had gone differently. This one missed. Others might not. But more than fear, Year 4 left behind something harder to explain, a sense of something unresolved, as if the encounter had meaning beyond math and mass. One astronomer, speaking off record, said it best: sometimes, these objects arrive just to remind us how fragile we are, and then they leave, leaving behind a silence louder than any collision. It's the silence that lingers, the knowledge that we watched something come close, too close, and had no power to stop it. We only observed, we only measured, and then we watched it fade. The sky today is calm, the night above us unchanged. But for those who were paying attention, who followed the numbers, who saw the simulations play out frame by frame, 2024, year 4, was more than a flyby. It was a visitor, uninvited, unexpected, unforgettable. It did not break our world, but it reminded us that something out there could, and that we may not see it until it's already too close. For now, this one is gone, but space is full of others. Rocks and ice, old fragments from the birth of the solar system, still moving, still waiting. Most will never come near us. Most will drift forever in silence. But one might change course. One might arrive unannounced, like year 4, and next time, the ending may not be so gentle. So we watch, we map, we calculate. But even with all our instruments and all our data, sometimes we're left only with wonder, and with the quiet understanding that the universe is not something we command. It moves, regardless of what we want. It reminds us, in the most unexpected ways, how small we are beneath the sky. And sometimes, all we can do is look up and remember that something once came close and chose to leave. 2024 year 4 won't be the last of its kind. It's just one of thousands of wandering shadows drifting between worlds. This time, we were lucky. But next time, when the sky grows dark enough, look up and remember, something might be looking back, waiting.